I was thinking about that. Like when she starts, everyone's just be like, "Hey, Mo."
Yeah.
Justin,
wait, are we gonna be here?
I'm sorry, I tried to kill you.
I don't know. This is the first time I've actually live streamed anybody.
Oh no, you can spell it.
Look, man, we don't talk about that. I got sorry for that shit.
She can even spell it. That's just a test.
You want to take anything that is edible, yeah, I'm done with those.
They taste like
I
plastic.
ate like half one.
They taste like plastic.
And found out they were waiting.
You didn't know they were wafers. You literally said you had wafers. And then you ate one and you're like, ew, I don't like wafers. Like, what?
Oh, because it says sticks. I didn't know it was wafers.
All right, guys, you have 2 new titles to add to your title page.
I bit into it, it was plastic. It's like a little kid thing. Like little kid kitchen.
Thanks, Justin.
What I'm talking about. Yeah, try and eat one. Where'd the last one? That's right here.
I'm gonna put my phone. I got all these. Girl, no, I got all these. Look.
Let me run down and see it.
She's about to do some baby monitor stuff with us.
I swear. He didn't know.
Right.
Your ball, you almost killed somebody.
Better not go to her.
Better what next?
Oh.
Bring a whole bag of shrimp. Oh, here you go, Mom.
Hey, Mo, didn't you say you would like shrimp?
Yeah, but that'd be messed up. Too. I
It
would.
would. I feel like you would.
I would.
I feel like you'd bring more and be like, hey, what do you
He
want?
sounds like a liar.
And that's like the worst you do.
Yeah.
I feel like he'd ask if she wanted one, but that'd be the worst he does.
I wouldn't do that. Y'all think I'm some type of evil. You're trying to kill her.
He didn't know.
What?
Oh.
I mean, I try to kill somebody too, but we don't talk about that. Right?
You do realize it's recording, right? Yeah, you caught.
See.
I thought that would have hurt. What else over here? Tripping on acid.
Girl, break the flag. I said tripping on acid.
Caffeine. Tripping on acid. We're tripping on acid, all right? Do that day. Tossing up ass.
No, it's.
Tripping on acid. Yes.
Wrong. D1.
That's some.
Oh, pro, all the time you take the Hall of Fame.
That's so fucking hard. I know.
Going to do more basketball?
I fuck playing basketball. I realize you don't know.
All right. Everybody say hi, Mo.
Sorry, Mo. Didn't know you was wiping shrimp.
Oh my goodness.
Only Justin.
Only Justin, right?
Yo, Justin's the only person who would try to kill me.
I love
All right.
Yeah, you
We are going to start with our second set of special right triangles.
What?
Okay. So, your second set of special right triangles are called 30, 60, 90 triangles. Again, this labels the degree inside of your triangle. Okay, so you've got to be careful where they put the degree so you know what side you are. So your smallest leg is always directly across from your 30-degree angle. So this is your small leg. You've got your big leg that's across from your 60. Okay, that's one thing that'll never change. So if you look at the second triangle I have there, your legs are going to switch because I switched your 30 and 60 degree. Okay, so if you're 30 degrees up here, that makes this your small leg. this your big leg, and this your hypotenuse. With 30, 60, 90, we always want to try to get that small leg. It's so easy to work with when you have your small leg. Okay, your small leg is going to be represented by X.
Always?
Always. Okay. Now, as I get bigger, my operation is to multiply, just like yesterday. When I went from the legs to the hypotenuse was bigger, so I multiplied by the square root of 2. So, to go from the small leg to the big leg, I multiply by the square root of 3.
Always?
Always. Your hypotenuse is always twice as big as your small leg. So to go from your small leg to your hypotenuse, it's 2x. Okay, so everything has to be based off that small leg. So if we don't know it, that's the first thing we want to do is find your small leg.
So hypotenuse is always going to be 2 times 3.
2 times that small leg. Yep.
That makes life a whole lot more easier.
Okay, so bless you. Let's flip it and go to example 1. Okay.
You said a whole lot more. So 8 is the smallest. That don't work.
The first thing I want you to do when they give you something like this is label all your angles. So if this one's 90 at E, F is 60, what does that make D? 30. Okay, so now, what information did they give us?
The small leg.
This is the small leg. Okay, they gave us the small leg. So, the big leg is the small leg times the square root of 3. So this is 8 times the square root of 3. And you leave it unless they want it in decimal form. Your hypotenuse is always 2 times your small leg. So 2 times 8, which gives you 16. Whoop, there it is.
Wait, Miss Smith, in your opinion, between this one and the one from yesterday, which was easier?
Yesterday's. Just because it's only one rule, you only have to remember you either multiply by the square root of 2 to go bigger, or you divide by the square root of 2 to go smaller. I don't think this one's all that difficult, but you have to remember that it's multiplied by 2 and the square root of 3. You've got to remember 2 different things. Okay.
That just seems easier to, like, even though you have to remember, like, the 2 and the 3, I feel like it would have been, it's, like, harder to remember, like, you have to divide by the square root of 2.
You're going to have to divide here too,
But it's,
depending on what they give you.
that's not fun.
Okay. So here we fill in our 30 degree. What do they give you?
Your big leg.
Your hypotenuse.
My bad.
Okay. This is your hypotenuse.
Oh, I was looking at the wrong equation.
Okay. This is your hypotenuse. So when they give you something other than the small leg, you want to try to get that small leg first. Where's my small leg?
NE.
NE is my small leg. Okay.
Right.
So your hypotenuse is 2 times the small leg. So to go to the small leg from the hypotenuse, we have to divide. So this is 14 divided by 2, which is 7.
It's pretty easy.
Yeah, see, it's not that hard.
Now that you have the small leg, we can go from the small leg to the big leg. And my rule there is to do what? Multiply by the square root of 3. So this becomes 7 square roots of 3.
See, that's
Okay. Let's go down to example 3.
They already gave you the big leg.
Okay. This time they gave you the big leg because here's your 60 degrees. So this is the big. Again, I always want to go to the small first because small can branch out to anything. So I need to go from the big leg to the small. To go from the small to the big, I multiply by the square root of 3. So we're going to divide by the square root of 3. So this is 9 square roots of 3 divided by the square root of 3, which comes out to be 9. These two will cancel, and you're left with 9. So now I've got my small. I need to go to my hypotenuse.
So
9 times 2. 18.
That was pretty easy.
It's not bad until you have to rationalize the denominator. Okay, all right. Try not to go too fast for our friend here. All right, let's scoot over. This time they give me what? That's your small. Okay, so what do you want to do first? Big leg or hypotenuse? Big leg, okay? So to go from small to the big leg, I do what? Multiply by the square root of 3. So that's the square root of 9, which is 3. Okay, to go to my hypotenuse, I would just multiply this by 2. So 2 square roots of 3. Try 5 and 6 on your own. Y'all are like, no. Remember to label what you have. And everything has to be based off of that small leg. Of course, these are the most difficult ones, too, that I leave you to do on your own. Oh. Just try it. You're better off trying it and making a mistake, and then we talk about it, than it is for me to just tell you how to do it. Because when you make the mistakes, you actually learn from them, believe it or not.
Don't you have to divide by 2 on this one? What?
Example 5, you actually have to rationalize the denominator.
Ow! My eye.
Is it really that bad?
Yes.
Yes. All right.
Like simple, but like it's so simple. It's like
All right. So what do they give us here?
Big leg.
The big leg. Okay. This is the big leg. Okay. We need to go from the big leg to the small leg. Divide by the square root of 3. So this becomes 12 divided by the square root of 3, which means I need to rationalize my denominator. To do that, I multiply by what? Or the square root of 3. So this becomes 12 square roots of 3 over the square root of 9. Okay, which I just heard somebody, I'm pretty sure it was Lydia, say that was 3. Was it Lydia? Sorry. I knew it came from back there. Okay, so the square root of 9 is 3. The last thing I need to do is, can I reduce that? What's 12 over 3 reduced down to? 4. So this is 4 square roots of 3.
Yeah, I was only 8 off.
Did anybody actually get that?
No.
All right. Okay, so now we're going to go from the small leg to the hypotenuse. So I have to do what? Times 2. So 2 times 4 square roots of 3. 8 square roots of 3.
I knew something was weird about that. I had 24. That's what I had. I just looked at it and I was like, yeah, it's the smaller one because like it's shown as the smaller one. So it's gotta be the smaller
This
one.
is why I'm telling you, you cannot
But it's
assume.
stupid.
Brandon, I don't care. You can say it's stupid all you want. They're going to do it. Why? Because people like you are going to fall for it.
But why?
Shut up, Grandma.
That's why you would sit next to me for the little chocolate bars just in here. It tastes like crayons.
Like through the whole thing again, or why it became 4 instead of 12 over 3?
You didn't want it? Yeah, I think I
12 divided by 3 is 4.
That's weird.
So that part reduced. Does that make sense?
Crayons.
Oh, you're fine. I'd rather you ask than be lost. All right. With this one, what do they give you? The hypotenuse. So Kinsey said my first step is to divide by 2. So 4 square roots of 3 divided by 2. 4 divided by 2 becomes 2 square roots of 3.
Hey, I got that right. Proud of myself. Yeah, A1.
Okay. So now I need to go from my small leg to the big leg. Multiply by the square root of 3. So this is 2 square roots of 3 times the square root of 3. 2 square roots of 9, which is 2 times 3, which is 6.
Good job. I'm so proud of you.
Okay, so obviously you can see if it's not a whole number, it can become difficult because you've got rationalization happening, then you're multiplying square roots, and the easiest one to start with is your small leg. If you don't have to divide, it makes it easier. Okay, so let me tell you this. How many of you do not like special right triangles?
Like triangles in general.
What I'm about to teach you, the rest of this, is another way to do this. So if this doesn't work for you, oh no, you've got to learn SOHCAHTOA. But you can also use SOHCAHTOA for special right triangles.
SOHCAHTOA.
SOHCAHTOA. All right. SOHCAHTOA. So you fold this just like we did yesterday. Fold it over so you can see example 5 and 6. And then fold this down so you, oh no, I did that right. Okay. I was going to say, did I print this wrong? And then fold it down so all you can see is your title. Yes.
You went way too fast for me. I can't even pick it up.
What? No,
Not good. Already folding stuff.
It's the same way as you folded it yesterday.
I was lost yesterday.
1, 2, 3, and 4 facing you. Hold it like a book. So you can see examples 5 and 6.
I don't see examples 5 and 6.
Because you folded it the other way.
Wait,
Oh, good.
Flip it around. Now fold it down.
are you okay?
And that's it.
That's it.
Oh, you were saying like fold it so you can see this and that, and I was getting confused because I wasn't like I couldn't like process
Oh,
it
Brandon.
because I'm slow. I take a minute.
Shut up.
This goes in on 126.
They was talking. They were taking name. They big.
125 should have had your.
I told you they was crazy. He's the only one that's okay with that. Let me get some, bro. I will beat you.
Stop.
I will beat you. What?
Okay. On page 127, I want you to glue in these 2 triangles.
Crap, we were supposed to cut those off. I thought that was something. Thing was funny.
Miss Smith is gonna kill you.
Shut up. Shut up. Not if I do it first.
Okay, that's enough. I've had enough.
For what page was it you said?
126 is where you glue in the 30, 60, 90. And 127, we're going to glue in these 2 triangles. Because now we're going to talk about SOHCAHTOA.
What was the thing? It was like some old hippie.
So while you're gluing this in, let me see if I can find this story. No, there's always a story. Chief. So.
Is there actually a chief named SOHCAHTOA? Oh god.
I don't want the PowerPoint. I just want the story.
Is this a story of SOHCAHTOA?
Yes.
That sounds like the Native American.
Yeah.
All right. I guess I just have to read it.
Is that a recycling box? All
right. So the story is based on the name of a great North American Indian who became famous for his wonderful problem solving in geometry.
Well, that's it.
In his tribe, they were renamed as adults with a name that represented either their personality or a great event in the tribe for which they were responsible. Bless you. The young man that we are speaking about was very smart as a boy, but he had a very short temper. When things did not go as he planned, he would begin to carry on, throwing, kicking, and swearing. A general temper tantrum. One day in math class, he grew frustrated with a proof that he went into one of his famous temper tantrums and kicked a huge rock. And kicking the rock, he ended up breaking his big toe. As soon as he broke his toe, he realized how silly his temper tantrums were, and he vowed never to throw a fit again. He became very patient and always used reason to work out his problems. He became an excellent mathematician. Even the problems that the chief had were sent to him to solve. When he became an adult, the tribe thought long and hard about a name that would reflect his great mathematical ability. But one wise old woman rose up to suggest that they name him for the event that changed him and made him a better man. To symbolize the dramatic moment in his youth, they named him for a regular event that he would continue throughout his life. The constant pain in his foot caused by the Native American to spend lots of time at the river cooling the pain of his forever mangled foot in the river waters. So they named him SOHCAHTOA.
So, wait, what?
Why didn't you just go to a doctor?
Wait, was this like? When was that? Was it like a thing?
It was obviously way
Way back in the day. All right.
But like for real.
So, Toa. SOH.
Do we have room under it to write like the way we remember it?
However you want to remember it.
Okay.
So,
We can do some obese hippo.
Caught another hippo.
Caught another hippo.
Touching on
No.
touching on it.
touching on apples. How about that?
Touching on
That's
apple.
weird.
No.
That's
They're
weird.
obese and they don't look healthy.
That wouldn't be right for princess. Princess
Yeah,
named
that would-
apple.
That would make sense.
Thank you. Only.
Okay, I don't care what you want to come up with to remember this. But if you can remember how it's spelled, you can remember how to set it up each and every time.
Wait, some old hippie called another hippie choking on acid and he don't.
Not tripping.
Tripping.
Oh, tripping. Okay, never mind.
I'm
Did you say
dead.
choking?
Yeah.
I'm dead.
That's what I thought she said at first.
All right.
So, I was like, okay,
So,
I'm worried about it.
When we have a right triangle, we can use trigonometry, which is about what we're about to do is trig. Okay? So, when you have a right triangle, you need to know one other angle, and we're going to call this is a Greek symbol.
Yeah, and if you put it in,
Theta.
if you put it in the calculator, you can make flowers with it.
This is theta.
Bro.
Okay.
Like
Not,
the
not,
cheese.
not theta. 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 We can know what y'all are thinking about food.
I really am.
Okay,
Yeah.
so again, hypotenuse will never change. So the angle or the side across from your right angle is still your hypotenuse.
But you said we can't assume.
I wrote it in, so now you can
But you
because I told
assumed
you it
it.
is.
But you assumed it.
I made right triangles. Okay, so the other two sides are going to be called your opposite and your adjacent. What does it mean to be adjacent?
Like cross.
Next to, side by side. Okay, so if I take my finger and cover up the angle that I give you, theta, which one of these legs is your adjacent? This one. The one that is touching your angle is going to be your adjacent side. So if you take your thumb or your finger or whatever, your pen, and cover up the angle that you're using, your adjacent side is the one that touches it. So this side is adjacent.
I don't get that.
Okay? Can't change your hypotenuse. So yes, while it still touches your hypotenuse is still always the one across from the right angle. Okay, so label that first. And then cover up the angle that I'm telling you to use and label your legs according to that. You have an adjacent leg and you have an opposite leg. Your adjacent, I said it before, I'm going to say it again. Your adjacent leg is the one that your hand or finger is touching.
Can't you just
What,
say
your-
your
it's where
adjacent
the
leg is the
angle
one that's across from the hypotenuse? Or is-
No, because this one's also across from the hypotenuse.
But they both
Like
touch.
that way.
Not if you cover up that. Yeah.
But depending on how you turn your triangle, it's not always going to be that same one. It's not always going to be that same way. Okay? Think about it this way too. If I cover up this angle, what side does my hand not touch? That bottom side, that's your opposite.
That's a better way.
Okay? If that's a better way to do it, the side that your hand or finger does not touch is always your opposite. Okay? So that makes this your opposite. Okay? You've got to use either the angle that they give you or the angle that has the variable to denote your sides. So, what I mean by that is if I come down here and I change and this is my angle now, it changes your legs.
Wait, so you go off of the angle.
It goes off of the angle that it's given or the angle that's the unknown. So again, now if I cover up this angle, where's my opposite? The side on the one on the side here. So that now makes this your opposite. Your other leg is your adjacent. And your hypotenuse, again, never changes. Okay, so let me try this. Let's try one more. I'm going to turn on this light for 1 second. Ready? 1, 2, 3. He says, All right, let's do. No, that's not. Trying to do something. All right, let's do it this way. We're going to label this A, label this B, label this C. This is going to be, not Q. This, actually, we'll just make this X. Okay? So, X on this triangle is going to be your reference angle. That's how you're going to denote your sides. So, if I cover up X, which letter is my opposite?
C. No, C. I meant that. My bad.
C is your opposite. It's the side that it does not touch. Where's your hypotenuse? Which means this is your adjacent. Okay, so no matter how I turn my triangle, okay, it's going to work out that way.
Can't see that.
Huh?
I bet most sad she can't see.
She probably is. So let me do another one on the notes so she can see that. You're probably right. She's probably sitting there cursing me right now. I love you, Mo. Yes.
I'm good. Shouldn't have been trying to kill somebody. Why did you do it both times?
Okay, so here's another triangle. Okay, again, label your opposite side first. Cover up the angle that they want you to use. Even if it's unknown, you're going to use that. So I'm going to cover that up. So what's my opposite side? B.
Oh, was we supposed to draw that?
What is my hypotenuse then? C. And your A value is adjacent. Okay. All right. So let me give you what we're going to use to solve. Notice you have an O and an H. What do you think that represents? Opposite hypotenuse. AH. Adjacent hypotenuse. OA. Opposite adjacent. So the way we're going to use this to solve, I can find the sine of any angle I want by taking the opposite side and dividing by the hypotenuse.
That's supposed to say sine?
Yes.
Is this doable on the
Yes.
And it's fun.
So the actual word for this is sine. S-I-N-E. What?
Really?
What?
So you're going to do it on the board, and then when you get there, you just fly through it?
She had to come down here.
She did all
the way down.
When she can't rewind, it's a live video.
But she can go back and watch it later.
She can rewind. But you can go back.
I don't like you anymore, Justin.
Sorry, Mom. Love you.
It's all Justin's fault.
He was talking about how he tried to kill you earlier.
No, that's not true. That's
You did try to kill me.
Right.
Love you though.
Murder.
Hugs and kisses.
Yeah, it was so true.
Yeah.
He was trying to kiss her with a strip, bro.
On the top of the building.
Okay. So, while you see sin, I use that because guess what? That's your button on your calculator. It says SIN. Okay? But that stands for sign.
Okay, what is the cosine of 10? Is it just cosine 10?
Okay?
Here you go.
Because, let me pull. No, you don't. That's all right. We don't actually need it today. We don't actually need them today. But here's your buttons that you're going to use. Sine, cosine, and tangent.
Oh, that's what they mean.
That's why I use SIN, so you get used to what you're going to use on the calculator.
My friend Craig used to do this.
So,
It's a long ass bit.
sine. Brandon, one more time, and it's a write-up for swearing. I'm done. Stop. Yes. Can I open? She says, okay, I'll loosen it. So,
I really didn't realize that's
if I have,
Oh, that's what that is.
yeah, that's what the SC&T stand for. Okay, so if you know the opposite and hypotenuse, you can find the sine of the angle. If you know the adjacent and hypotenuse, you can find the cosine of the angle. That's what C stands for. So sine, cosine. If you actually spell this out, this is C-O-S-I-N-E. Cosine. The last one has to begin with a T. And this is tan, which stands for tangent. So if you're going to find the tangent, I need to know the opposite side and the adjacent side. So I'm going to show you how to solve using all of this tomorrow. All I want you to do today is I'm going to give you cards and we're going to sort them. Okay, so that's what your little pockets are for. Pockets! So you're going to fold in the sides and the bottom and glue these in as pockets in your notebook. Or if you don't want to fold it, you can also just glue it in. Just make sure that you don't glue the middle part. Okay, so you can either glue it in like this and just glue underneath these little flaps, or you can fold them under and glue them. I don't care which way you do it.
How did you glue yours?
I haven't glued mine yet.
Oh, did you just put the thing on the
So you can either, again, you can glue it in like this and just glue underneath those tabs, or if you want to get all fancy, you can fold them so it looks like this. You can fold them and glue them in so it's like this. And just glue the tabs on the back down so you still have a pocket. It does not matter which you do. Okay. So somehow get these 3 pockets into your notebook. So I can go back here so Jen and I can get whatever the heck she missed here. Oh, I need to walk these down to know. It doesn't matter what order they go in. Okay, it does not matter what order they go in. All right.